One more video on solving, and these get a little bit more complicated. So for this first example, we have a whole bunch of radicals here, but we cannot just square both sides and have all of our radicals disappear. On the right side, that's fine. That's going to give you x minus 6. But on the left side, that is not okay because our radicals are separated with a negative sign. And even if that was a plus sign, that would be the same. So think about this. What you're actually doing is the square root of x minus the square root of 6 squared, which is the square root of x minus the square root of 6 multiplied to itself. So if you were to FOIL this, the square root of x times the square root of x is going to just give you x. And then the square root of x times a negative square root of 6, and then a negative square root of 6 times the square root of x, that's going to give you minus 2 square roots of 6x. And then finally, negative square root of 6 times the negative square root of 6 is just going to give you a positive 6. So when you FOIL that, you're going to end up with that. So now you're going to have to combine like terms, simplify a little bit, and you're going to have to get rid of another radical. So what you need to do here is you're going to need to subtract 6 from both sides. So that's x minus 2 square roots of 6x is equal to x minus 12. Now you need to subtract this x. So that's going to give you a negative 2 square root of 6x is equal to a negative 12. And divide both sides by a negative 2, so the square root of 6x is equal to 6. So now what you need to do is you need to square both sides again, and that's going to give you 6x is equal to 36, so x equals 6. Talk about a lot of fun with that. And if you were to substitute that back into the original equation, root 6 minus root 6 is 0, and the square root of 6 minus 6 is also 0, so it works. Our only solution is 6. So these questions get a little bit more complicated, but as long as you follow the rules, it should be a piece of cake. Number 2 is a little bit different. Now we're raising 3 to a 2x, so now our variable is in the exponent. So to do that, the best way is to see if you can get both bases to be the same. Luckily, we can rewrite 27 as 3 cubed. And that, by just doing that, we have 3 to the 2x is equal to 3 cubed to the third power. We know that we can use our exponent rules. When you raise an exponent to another exponent, you multiply. So we have 3 to the 2x is equal to 3 to the 9th power. Now the other thing you know is the only way that 3 to the 2x can equal 3 to the 9th is if they have the exact same exponent. So if the bases are the same and have the same exponent, they're going to have the same value. So you can ignore the bases here since they're the same and just set the exponents equal to each other. So 2x is equal to 9, so x is equal to 9 halves. Substitute it back into the original problem and it'll work. So you get 9 halves as your only solution. Okay? Moving right along to number 3 and number 4. If you'd like to try these problems on your own first, of course, just pause the video and give it a try. Number 3, we have 1 over 11 to the x power is equal to 1 over 1331. And that's because we're not supposed to have negative exponents. So what are we going to do here? Well, notice they're both 1 over 11 to the x and 1 over 1331. So what you can do here is you can set 11 to the x equal to 1331, which so happens to be 11 to the third power. So since we have the same bases, we just set our exponents equal to each other, and you get x equals 3, and that will work. So our solution is 3. Final example. This one's a little bit tricky. Again, we're going to need to get common bases, but this is going to need a couple of different common bases. So first of all, we already have a base of 2 here. This can't be changed, so this is 2 to the x minus 3. We can rewrite 16 as 2 to the 4th power. And we can also rewrite the 5th root of 4, because remember 4 can be written as 2 squared, and a 5th root can be written as a 1/5 power. So the 5th root of 4 can be rewritten as 2 to the 2/5 power. So now we have 2 to the 4th times 2 to the 2/5, which is equal to 2 to the x minus 3. We got the same basis, so we're good to go. Except for we got to simplify the left first to have 1 base of 2. But we know when you're multiplying, all you need to do is add the exponents together. So 4 plus 2/5 is going to give you 2 to the 22/5 is equal to 2 to the x minus 3. So all you're going to need to do here is set the exponents equal to each other. 22/5 is equal to x minus 3. Add 3 to both sides, and you're just going to finish with 37/5. And you are good to go. So again, this video is just to show you for a little bit more challenging examples and to help you out with some of your homework. All right, this is Longo, and I'm out. See you, bye.